Who has used an agentic learning agent before in this class? Not in this class, but before in your life. Hmm. Have any of you used a robot before? Okay, I might classify that as agentic agents if I'm going to be going over this definition today. So we were covering a lot of stuff previously about talking about the right problems, making sure that the things that we're going to study and build algorithms towards for agents end up being things that are like going to be useful and interact in the real world. So as a interesting kind of parallel to this, as the language modeling community grows and tries to basically engulf everything else, they're discovering this new concept called agency in developing agents. But what they mean more in this case is like most of the time, I would suppose when you're using an LLM, it's, like give me the answer to 7 plus 5 or something like that. It's like fetching information that's more or less stored in the parameters of the network. But the idea more so recently is, well, how much more can these models actually help with? Can it do something as nice as, creating additional tools, using those tools? So like adding something directly to your calendar, maybe something like that without actually having to go through it specifically. There's a lot more to that, but we'll get into some of those directions. Really, the overall idea is want to deal with a couple of different challenges. So there could be tools and interfaces. Really, you want to be able to do queries like this. Like normally it's this problem. Some people have probably used like Copilot for generating some code. But what if maybe at some point, if computer security is good enough, you can just ask your buddy LLM to purchase tickets for an upcoming concert, to figure out when and where your class is for the next day and plan your like path to be able to get there. So the agentic part here literally means at least like taking some automated actions for the user or client, at least inside of some large software system where like normally you could do all this stuff as a human, but now a lot of APIs need to be made in order to like facilitate this agentic behavior. Okay, does that make sense? Sort of, I don't know if you've probably, has everyone seen the Iron Man movie from Marvel? Maybe as an example. So often the person in the movie would ask, "Hey Jarvis, like clean my kitchen for me," or like manufacture the robot in this color. So that's way more than just being like, tell me what time dinner is ready, which is just information seeking, not acting in the world through some interface. Okay, so this has been growing a lot in popularity, which is also great for us because we are studying reinforcement learning and agents here. So it's just another version of a lot of the kind of frameworks we've discussed before. So in terms of just like interacting and in learning, there's still quite a few challenges with getting agentic models to learn. Well, they're starting with just being able to make models that can answer some queries, learn online in an interactive sense. Okay. So I'm going to give a few examples of some recent pieces of work. So one of these, since we're also talking about safety in the last lecture for a bit, is figuring out if you can basically ask robots and the robots will also ask for help. Really, you want them to figure out when they don't have enough confidence to complete the task, given the information that was given, like from the person that specified the task. So if there's this example, all right, some robot, puts some bowl inside the microwave. But in the particular situation, there's going to be 3 bowls. One of them is going to be metal. So at least if any of you has not done that before, if you put something metal, in particular like aluminum stuff in the microwave is a really bad idea. It might destroy your microwave. But because of this, like the robot should then at least ask, I mean, even if the robot doesn't have enough information to understand that metal bowls are a bad plan, if it does know that, it can figure it out, but then there's still 2 bowls left and it's not sure which bowl to put in the microwave. So it should have like some understanding in the model that basically specifies like this, it doesn't have a confidence enough to answer this question, like to perform this task well enough. So it'll basically request back to the human or whoever is operating it, probably human. Basically, the robot can then ask, okay, which one of these bowls did you actually mean? And then with that information, it'll have enough basically context to answer the question properly. So the idea is just, the idea would be able to ask for help. The challenge in this is this taps into a really long standing area of the robotics community and like really machine learning in general, which is related to uncertainty quantification. Like it needs to somehow realize that given the information it has, it's like unlikely to complete that task some way. So in this paper called the no paper, um, basically they constructed this in a couple of steps and used a little bit of a like clever way of activating the LLM. So it's still the same problem, like please place a bowl inside of the microwave. Sometimes asking please helps. Haven't really tried that as much for the robot. But then basically the overall system can specify a bunch of next steps. So like this is the plan that could be generated given that context so far. What the model uses is something called conformal prediction. So conformal prediction is basically you want the model to be able to specify outputs and then have some measure over like it's only going to give answers that are at least by some threshold going to be correct. So if you wanted a model and you want all the answers to be 90% of the time to be correct, you can use something like conformal prediction to train that model to be correct for 90% of its answers. You don't always know which ones are which, but it's like a nice way to start to guarantee outputs. So it needs, with at least with conformal prediction, it means that for every output that comes out of the model, there needs to be some probability that's going to measure whether or not that's going to be successful. And then conformal prediction will basically say, okay, from all these actions, like this one only has a 0.44 chance of being successful. So if none of the actions meet that threshold for conformal prediction, then it's either not going to act. In this case, the robot design here is it's going to ask for help. So it needs more information to hopefully get some of those probabilities high enough for it to be like understanding and with confidence enough to actually make a good choice. So for example, here that conformal prediction threshold is only 0.221, which is pretty low, but that's enough to at least filter, okay, these particular like plans or actions should be successful, at least according to that threshold. Yeah. Um, so like for getting these numbers. Yeah, okay. That part's on the next page. So that's prediction size. We can kind of skip some of that. So they basically did it this way using the LLM. So ask for the scenario and like some test data. But basically the kind of clever thing that they would do here is given all of the possible outcomes that the LLM would generate, it would basically add A, B, C, D, E before them. So it'd be a single token, hopefully, for those A, B, C, D, Es. And then they would use the token prediction probability for one of these particular characters as the likelihood for their conformal prediction. That's like the confidence that the model will predict this next token because that should be a way to be able to complete the task. So it's a bit clever. It's probably not perfect as like a model for what will be done next. It's maybe sort of pseudo um, confidence aware and what the model's going to do. But it's I wouldn't say it's too bad. It actually seems to work pretty well on the paper as a place to start. And then maybe people can build on this in order to get a better estimate of the confidence of the model and its actual prediction. But actually, like right now in the community, being able to estimate confidence in predictions out of LLMs is a very tricky endeavor because the models are huge. And the usual solutions are to do ensembling, which means make multiple copies of your big giant model. So it consumes a lot of memory. Those work well. We talked about those earlier in the class. Or using Bayesian networks, which is even more difficult to train than even transformers as they are. And yeah, in this case, they could just define, like find some score threshold that gives like good answers for like the highest quantile, and then only when answers out of the model give a next token prediction probability above that threshold will it try that plan. If not, it'll ask the user for more information to try and be able to get some of these values above that threshold. Okay. Makes sense? Other questions? So this is I mean, this was actually a pretty good paper. It was a pretty good design by them as well. And they went through a number of different ways to be able to show that this can work. But this is kind of like one of those, like, I mean, a robot in general is an agentic model, but here it's like ask the LLM, which then controls the robot and does something. So it's definitely doing something in the world, given just some language model input. Okay. So I also wanted to revisit Gemini robotics here, because it's at least certainly calling itself a large agentic robotics system, because now this is a balance for this robot. We talked about how, because of the large Gemini model, it can basically query itself in its own API. So in that case, this process can be done where goals can be given to the robot. At least in some of the demos, they were like in audio, which eventually gets turned to text. And then that agentic system then can query its own API to figure out, okay, like find the location of the bowl in the image, find the bounding box for it. Because all those are needed to complete the plan for, like, I don't know, moving the bowl around on the table or putting the banana inside of the bowl. So this agentic system, it's a bit of a different one because it's using itself as its own API. It doesn't have to figure out how to call other software libraries and figure out transactions. But because of that process, it's actually become a fairly agentic system. And it, at the moment, doesn't have to deal with software from a number of other companies that have to interact and be able to find solutions to the specified plans. So this is kind of like a nice, like closed software ecosystem version of making an agentic model. And the agent here is obviously the LLM that gets to control the robot. It's kind of an odd way of thinking about this, where normally the agent is like the mind of the robot, or even part of like the physicality of the actual robot, but here it's just the LLM is the agent process. Okay, does that make sense? This is like interpreting some versions of agentic systems that have been made so far. Robotics are an obvious one. This one's a little more a good meld between what the LLM community would call an agentic system and what we would just call like a learning agent that we're familiar with. Okay. Um, so then we can take this kind of concept pretty far, and we can talk for a bit. And I'll ask this question to the group as well. Okay. So maybe related to the conversation of agentic stuff, why are humanoid robots so popular? Is it just we really like ourselves and our form, or is there more to it than that? Hmm. Yeah. So then how far can we carry that like conceptualization for that problem? Like I'll give an example. Sure, a lot of the AlphaGo work, and I think it was like Alpha Zero or Mu Zero work would show like a computer system playing chess, which was a great accomplishment. But as a robotics person, I was sort of like, well, I want to see the robot playing chess across from it, the person and like physically interacting with the robot, not necessarily doing it all over a simulated computer system. And then you still need a person to actually make the agentic chess moves of the system in the real world. Because it's, maybe a bit disappointing. But then how far can you go along this path for what people can do? Maybe, I don't know, other thoughts on why humanoid robots are awesome, besides just this interface part? Mm. Yeah. Are you also getting to, because they're like us, it might be easier for me to show a humanoid robot how to do something than it would be for me to show an elephant how to do something. I have no experience with elephants, and maybe elephant trainers would. So yeah, that's part of it as well. And they all kind of revolve around this concept. Um, if humanoids can be this general interface, then basically the most agentic system we can make right now is probably a humanoid robot. So instead of having to figure out how to make software to allow some agentic LLM to actually book stuff in my calendar, I could just have a humanoid robot use my computer, type in all that stuff for me. Doesn't actually have to worry about making software. So in many ways, I don't know if this is really the plan of a few of these humanoid robotics companies, but in the long run, this is one solution to getting around to having to make a software API for every single thing in the universe that an agentic system would have to do. You just have to give this one your like user password for your laptop, and then you'll probably be fine, as long as you trust it anyway. Does that make sense? This is like this is what I mean by like going really far with this interface idea. Back to the typing interface that humans have to use to interact with technology. Mhm. Yeah, have you heard of there's like at least a web agents competition, things like that? So developing agents, not specifically LLMs, that'll work through what is essentially the browser navigation to do these tasks. Yeah. So it's like one way to try to do the agentic part without having to make APIs for every, I don't know, website or interface. That's another version to be able to do this. I would still prefer to have a robot sitting at the desk moving the mouse around for now, at least as my solution for maybe covering all possible problems. Mhm. Mhm. Yeah, certainly one way of doing it. Although we also talked about in the last class about using human robot collaboration systems, and there was one for figuring how to type using just tracking eye, like looking directions. So maybe the robot only needs eyes to be able to navigate the system well. And maybe people only need that someday. Potentially, yeah. So there's maybe some easier ways to get around that interface. But for a lot of other things, the general version be like make some pretty humanoid copy of something that can do most of the tasks. And hands are really expensive and hard to make, for sure. Yes, they do. I I don't buy very many delicate hands because we break them really fast. Yeah. Sorry. Other questions? Comments? Okay. But all right, so there's an additional bonus to be able to go down to this route. Um, and this is a little bit to do with tool use. We talked about this at the beginning of the previous class. Okay, but if humans end up being pretty well designed and then humanoid robots are designed after humans, if a really intelligent humanoid agent ends up making something that is useful for them, I guess if they invent a hammer or a faster hammer or something like that, because if it's good for that robot, it should also be good for us to be able to use to perform tasks faster as well, or more efficient, something that's actually related to that. Does that make sense? So like now it's sort of like you've got a little bit of some extra people that need to recharge but don't need to sleep as much, but they can maybe iterate on designing maybe like more comfy and nicer chairs that could be in classrooms. Something like that would be a good option. So this is where, and part of the research I do these days, and a lot of the reason for making like these generalist policies is having a robot that, all right, if you can now put it in like a wood shop, which is just at least my example, tell it to start making, give it the option of having that when it's figuring out how to plan many tasks. And it's the reason that, we make certain kinds of tools, usually because those tools are very task agnostic. Like hammers are just to kind of like drive nails. They're like an adhesive device. There's not too many, well, there's lots of specific use case tools, but I gave up trying to buy all of those in my kitchen because it was weird just having a tool for an individual thing all the time. But those like more general use tools that make things like more, make planning or yeah, planning more efficient or more robust. They're a good design and it's really hard to do this stuff. In fact, like a lot of tools are accidents in human history that end up, oh, this actually oddly looks better than how it was originally designed or used for. Okay. Great, makes sense. Okay. So now we're going to go on to the next set of slides. So that was everything more or less related to agency. Covered some of the stuff on agentic behavior, but to be honest, the entire class is agentic models. Nothing about it is not. All right.